Making a video, draft science video, draft physics really. But anyway, um, so not much useful commentary in the last video, in a technical sense, and no response from the Piro in terms of making a video. So I'd rather do video exchanges with somebody who would like to discuss fundamental theoretical physics. Yeah. So anyway, I have some notes, so I'll go through my notes for the week, for the last couple of days anyway. Just stuff I was thinking about, stuff I didn't write down, but I guess I should as I make this video. Polarization, I was thinking about it some more. And, I'm quite confident. Like, okay, so let's give it a number. I'm 80% confident, that gravity is polarized, like light. That gravity is just photons without frequency, and that does carry this polarization idea. And I don't think it would work, the idea that I had where, the first half photon could be a little bit out of alignment with the second half photon, and that creates polarization in different directions because the alignment doesn't match, and therefore they wouldn't be able to go through certain gratings, certain filters. So I don't think that works for the gravity thing. And the gravity thing, I'm saying the polarization is what creates electricity and magnetism, is the fact that you can polarize gravity. So I'm thinking spin is probably the way spin is, is a good candidate. Whatever, 40%, I don't know what the number would be. Not highly confident, but it just seems like that might be, because you could sort of imagine that in a grating circumstance, if it's spinning with the grating, it's more likely to get through. If it's spinning perpendicular to the grating, spinning horizontally, going through a vertical grating, that it's more likely to be hooked, spin into when it hits something. That you would have that idea of not 100% kinetic exchange of directional information, but instead, if the spins are compatible, that the two things would combine a percentage of their directional information, and both things could end up going off in the same direction. So two things come in, both leave the same way. They give half of each. They give half of their direction to each other. Well, anyway, so spin could have something to do with that. But anyway, it's not terribly. I don't think it's not a critical thing to be able to describe what the mechanism is of polarization. The more important thing is to understand polarization exists, and that it has a significant impact on the reactivity, the ability of the thing polarized to react with other stuff. Yeah. So, so I was thinking of the reflection again, surface reflection, diffraction, and I think one of the proofs. See, Feynman had done a video presentation in whatever, the 60s, somewhere in there. And in it he said, okay, he talked about top surfaces and bottom surfaces of glass, and doing the Newton glass thing. As you make the glass thicker, the reflectivity of the glass changes, and it has a cycle. It goes from 0 to 16, then back to 0, 16, 0, 16, so it goes through this gradient, this sine wave of predictable pattern. So the pattern just repeats as it goes through the surface. So as you make the surface thicker and thicker and thicker, you just keep repeating this pattern from 0 to 16 in terms of reflectivity at a certain frequency. And then later, in the question period on the, he admitted that no, it's not exactly what I said. The light is reflecting from all from the entire surface, and there's an infinite number of these reflections. You use the word infinite when there really isn't, but he just said there is, and that they're just summing them, because all these little tiny probabilities don't mean anything. Well, anyway, and so ironically, he was right the first time, though. Well, he wasn't right in that there's no reflection off the bottom of the glass. There's just reflection off the top. And he sort of joked in the video about how, well, what, does the bottom of the glass tell the top of the glass how reflective to be? I mean, how could the glass know how thick it is? And I'm arguing that the glass does know because of the effect it has on the atoms that make up the glass. And my point about glass basically is that glass is, because of the arrangement of the molecular structure, that it basically creates a bunch of pathways, and the light gets reflected when it misses the pathway. So there's a bunch of pathways, 80% pathways, 95% pathways, but they're all pathways. And when light hits at one of those pathways, it spirals down, so to speak, that pathway and pops out the other side at the same angle that it went in at. And that's what light does when it transmits a photon, is the photon doesn't go through the light straight. It gets captured and it goes through, the energy of it goes through the atoms. The atoms exchange the photon and produce a photon at the end that's basically got the same momentum, the same energy that the photon had going in. And that reflection is just missing the pathway. And I would argue that as you change the thickness of the glass, what you're really doing is this atom pathway, you're changing its compression. You're compressing it more and more and more and more. Or, because there can only be a certain number of atoms from the top surface to the bottom surface. And if you're halfway in between the size of an atom, like you can't add a full atom at the top, well, then you have to compress what's there, or expand what's there. And it's that compression and expansion that creates the conduciveness of there being reflection based on the wavelength of the light. So you could sort of understand that if the atom's compressed and the electron is in a tighter orbit, that tighter orbit would change what frequency of light it would be able to capture, because it won't be in the same place. So when the first half a photon hits, it won't be in a full cycle. So when the second photon, it won't be as conducive to being captured if more of the atoms are compressed. And the percentage of atoms compressed will increase as you get certain layers of glass. And I think that can explain the phenomenon anyway. But there was a certain irony in that Feynman's first, the actual truth is that the surface is where the reflection takes place. And I think we can know that for a certainty by just measuring the speed of the reflection. We know that the light slows down going through the glass by 40%. So it seems pretty obvious that if there's no reduction in the speed of the photon and getting the reflected light is the same, there's no slowdown, that we know it didn't go through any of the surface or any of the glass to be reflected. Presumably, intuitively, superficially. Superficial analysis would say it certainly didn't reflect as it was going through one of the pathways, because then it would be 20% slower, or by some percentage of how much glass it went through. Slower, retarded in its progress would probably be the better way to say that, right? Alright, then another thing about Feynman, since I'm on the subject of Feynman, is the clock analogy. And this sort of relates to an old Hofladay video that somebody linked me to that I already had seen, but I responded to, but I guess I could respond to it better. He made a point about polishing the glass, and that somehow this would be a reason that there'd be no interactions with electrons. But of course it doesn't. I'm not talking about irregularities. I'm not talking about convolutions and bizarre structure. It's just atomic structure itself. Photons aren't interacting with matter. They're interacting with electrons that are part of atoms in empty space. They're just not they're not hitting a big solid thing. From their perspective, they're just interacting with an atom, and more precisely, they're just interacting with an electron. From their perspective, that's what they see. They don't see big giant matter. They just see the one little tiny moon in the solar system that they're interacting with, so to speak. So polishing wouldn't have anything to do with any gravitational effects created by matter. And it certainly wouldn't have anything to do with the periods of electrons and all that kind of stuff, beyond what I've described as a difference in density of atoms. And as you change their density, you change their size. You know, and orbits are changed of the electrons. There's flexibility, let's just say. The atom isn't a standard, rigid, only this size. It flexes. All right. So the other Feynman thing was this clock idea of measuring distance by using this clock. You know, the spinning clock, and taking a vector and saying, you know, this is how you deduce probability, or not deduce it, but define it or describe it, detect it, wrong word, well, whatever, is to take the area of the hypotenuse of the triangle you create by the two different 3 o'clock, you know, 10 o'clock. When you create those two times on the clock, you create a triangle, and it's the hypotenuse and the square of that hypotenuse that would give you your probability that you'll be in the cycle, that you'll be in the where you'll be in that from 0 to 16 kind of circumstance. Better to say that. So it's just a way of representing the probability, and more specifically, it's just a way of representing the fact that it's a repeating pattern, that the pattern repeats. It's like a clock. It's just 12 numbers. I mean, 12 positions. There's 16 probabilities, and you know, what defines the probability would be the extreme, the 12 o'clock to 6 o'clock. So, you know, it cuts the clock in half, essentially. But anyway, it's just a way of representing a repeating pattern. Also, besides representing distance, time represents distance in a way, in a very explicit way, if you're using the constant of the speed of light. So with a constant that is the speed of light, time and distance become a measurement of the same thing, just like wavelength and frequency and period are all really the same thing. I wrote down location changes, what frequency of light is something to be reflected. Yeah, whatever. So that's the compression of the atoms part, but I don't want to get into that again. But I did want to say something relevant. It's just, okay, so in the two-slit experiment, all these things, I'm just saying if people are willing to just say, well, let's start over, and let's not presume any wave theory of light, and let's not presume any particle theory of light, and let's just say, what do we observe in these experiments? And I think if you're fair to those explanations, fair to the understanding that what you're really talking about is a nuclear reaction. I mean, everything's a nuclear reaction in a way. Everything has to be understood as a nuclear reaction. Any vibration that travels through us, any kind of thing that it only happens, it only gets communicated across distance because nuclear bits, subatomic particles, do the transmitting. it's I guess you can't say the only thing, because I could take a piece of paper and write something on it and then move it from here to over here, and it's going to be hard to see the nuclear bits doing that. But obviously the movement from here to over here is nuclear bits. All that stuff has to go from here to there, all of it. Every one of the little nuclear bits has to go from here to over where I place it. And that was another subject I sort of brushed on in the last video, was the idea of a vacuum. And the idea, I guess what I wanted to get to was the fact that the matter is in the same empty space we're in. You know, the same space. And the space is completely permeable. And the only thing that indicates this vacuum idea is the fact that there's some nuclear bits, some stuff on one side of a barrier, no stuff on the other side, kind of a thing. And you're just really talking about moving stuff from where it is to someplace else. And you could just argue that, yes, you're pulling it, you know, with a piston or something. And you're doing that because there's a molecular connection. The things are gravitationally, electrically, magnetically, it's all gravity, but they're connected to each other. They're being held together by this pressure that exists in space, in everywhere. And that pressure is what makes it possible to pull them out or move them together collectively, is that they're connected to each other. And the entire structure of the atom is all connected to each other. So even though there's directional bits circulating an electron, they're all connected gravitationally. So when I move one, I'm going to affect all the others, because I change the gravity balance of the system. And you can't, if you do that, you're going to change everything else, depending on how substantial the movement is, how substantial the change is. Yeah, so everything's going to have to eventually go with it, just because it'll go where the gravity is. Sort of. So yeah, but it's just this idea of a vacuum. The idea of an impermeable space is kind of silly, right? Even though there's something called solid steel or something, and there's this tight bond between atoms, empty space still could flow through it with no problem. It theoretically can move through empty space without there being any resistance. You know, it could go from here to over here, and there's no resistance of the medium itself. The only thing that can create resistance to that movement is some other stuff that's already occupying the space that will now have to be pushed out of the way before you can take the space it has. So yeah, it's just this idea of a vacuum is kind of silly in the sense that there's no real impervious matter. I mean, all matter is pervious to space, theoretically. All right. Not an important subject, but sort of interesting. And it gets to this idea of how strong the pressure really is. We're not feeling it, but there's this incredible pressure forcing everything together. And you can sort of realize that when you do create some kind of vacuum, because then you see what the real pressure is of the matter. What's the right word to use? The strength of that gravity that matter is creating, and how strong it is in terms of bonding things together. It's a better way to try to express that. But anyway, so in overview, I want to, you get to this idea that it's just addition and subtraction of this directional information. Something goes in, something comes out. And what happens in the function of the universe is that these exchanges end up being patterned. They end up having an order dictated by the mechanism of gravity. So, as I pointed out, if two things are passing each other a certain way and there's this pressure, and they're blocking the pressure, they're going to be forced into a relationship with each other. And that's the exchange of direction that's taking place, is the pressure just keeps maintaining that relationship. It keeps exchanging constantly, this for this, and then this for that, and this for that. And so it's only the imbalances that you see. So the pressure's completely balanced, and then all that makes something visible, in terms of calling it energy or calling it movement, is the fact that some imbalance is created on one side or the other. More going this way when in, and more going this way when out, and so therefore the thing has to go that way. It has to go however the addition is. Whatever moreness was created or blocked in its environment. So everything is being affected by just stuff out around it that is changing the balance of the its disposition, what it's collected as a group of arrows. And so we've collected a certain imbalance in the sense that the earth is moving us, by spinning. Then there's the movement of the earth around the sun, and then there's the rotation of the entire solar system potentially. And so we have these collected directions, but they all have to be summed into a product that's a net imbalance. The net is all there really is. It just has to do with how that changes our shape disposition of the matter inside of us, because it has more. It can't be a perfect circle because there's an imbalance. So whatever imbalance we have is going to be reflected in some sort of imperfectness to the circularity of our gravitational order. Something like that. And until some other force changes that's the way it will stay. I mean, once you have collected more arrows in a certain direction, you have to have more arrows in the opposite direction to take those away, kind of a thing. So yeah, that's getting in deeper than just photons, and I really don't want to do that for now. But that's the context, so you have to talk about it a little bit, because as I'm arguing, photons are just one kind of quanta, one expression of it, and that the more significant expression of it, the bigger, the more abundant, is gravity. And gravity is not a force. It's a application of real material substance, energy, whatever you want to call it. It's just that it doesn't its native tendency is to be equal, and that it's only little pockets of imbalance that change that, and those pockets of imbalance have their rational expression, which is they radiate an imbalance back out to the universe. So the the imbalance that's created by the creation of matter creates an imbalance in the sense that matter now creates gravity, creates an imbalance effect on the universe. It's probably not the right way to say it, but close enough. So yeah, probably enough. Yeah. So till the next time, until I can find somebody who wants to argue feasibility, reasonableness, what's a better word for, I mean, the quality of different theoretical interpretations, different imagined causes for what we see as effects. Yeah. All right. Until next time. So forth and whatnot. Yeah.